Hello everybody, my name is Juan Icaza and this is the product that I'll be redesigning for the project. This is the original onboard truck, this is the full assembly, and these are the pieces of the product, and I'll give more detailed information about this and all of the details on the following PowerPoint presentation. Today I will be redesigning the original skateboard truck. The background: the truck is the axle where the wheels are mounted. What makes this truck special is that it uses a spring system and a wave cam to allow the user for sharper turns. Some of the problems reported with this type of design is that it is too bulky and heavy, and the wave cam has a tendency to break. This project will be divided on three parts. The first part will be designing the complete product through the use of cryoparametric. The second part, I will choose a part suitable for CNC milling, and the third part will be dedicated to implementing DFA and DFM in order to improve the product. These are the parts that make up the truck. So here we have the base plate and the hanger, the tension spring, the keeping, the wave cam, both bottom and top. These are two different washers with two different sizes. This is the lock tab, a small bolt, the kingpin knot, the knot for this is the riser. Here we have the full assembly and the exploded assembly. The exploded assembly, we can see how each part that I mentioned before interacts with each other. What we see right here is the CNC toolpath for the wavecam. The reason why I chose the wavecam is because I believe the base plate and the hanger are better suited for casting. So the manufacturing plan, it was done through the use of cryoparametric. The first I used volume rough, then surface milling, and then I only used one type of drill, which was the end mill, because the wavecam is actually very small and it's made out of polyurethane. DFM is a process of proactively designing products in order to optimize the process of manufacturing. What I decided to modify here was the wavecam, but I will also mention the base plate because I will also modify it through DFA, and the kingpin because I believe the kingpin can be replaced by a 3-inch hex bolt, which would make manufacturing easier. So the new design of the wavecam, although it looks similar to the old one, this one has a smaller contact angle. So this means that the wavecam is less prone to breakage, which also the small contact angle makes manufacturing easier and it makes it safer for the user. As I mentioned before, one of the problems of this design is that it is too bulky and heavy, so the base plate has a big chunk of metal removed. For DFA, I decided to modify the base plate even further. I decided to create a small protrusion in order for one of the washers to be self-locating. I also modified the hole where the kingpin is located so that the kingpin fits smoother and it self-locates. Here we see the modified product. As we can see, the base plate has the modifications that I mentioned both on DFM and DFA. The wavecam also has been modified, and it looks very similar to the original product, but it has very subtle differences. Results and conclusions. Through DFM and DFA analysis, we found that the wavecam, the base plate, and the kingpin can be improved. The base plate had 3 modifications in order to make both manufacturing and assembly easier while making the piece lighter. The wavecam had one crucial modification, which is the angle reduction. This makes the piece more resistant to fracture, but I still believe that more triangles with different angles variations should be experimented. The kingpin can be replaced with a standard hex bolt of 3 inches. Thank you.